Because we had a few extra minutes Wednesday, we went ahead and reviewed synthetic division so we could start more quickly today. These are the two examples we did, and I kind of gave you a preview of what 5.5 would be about. In 5.1, that last night's homework, you learned to graph pretty well anything that I gave you in factored form. You learned just to look at whether the degree was even or odd, and whether the leading coefficient was positive or negative. That's how you got the end behavior. How did you find a y-intercept? You let x be 0, and then how do you find the zeros, the real zeros, or x-intercepts of that function? Let y be 0, and then just set each factor equal to 0. Well, that's easy enough when it's given to you in factored form. 5.5 is, what do you do if it's not given to you in factored form? Just a preview of what's coming. Problems just like last night's homework, graph the function, but it's not factored, and what do you do then? So that's what this is all leading up to. And y'all just bear with me for a few minutes. I'm pretty good at making light bulbs come on, but sometimes it takes a while. There's a bunch of build-up before you finally go, oh, that's what it is. So just hang with me until we get to that light bulb coming on point. All right, we've done the first two examples. The next two examples say, use synthetic division to find the quotient and the remainder when f of x is divided by g of x. We're given two functions, f of x and g of x. We want to divide the g of x into f of x and give the quotient and the remainder. Now remember, you look for any missing terms, and this is a fourth degree polynomial. I have my fourth degree, third degree, second degree, first degree term, but I'm missing a constant. You have to treat a constant just like any other missing term. So I put in a 0 for that constant, and that's why this first row of synthetic division has a 0 at the end. Make sure that if I give you the divisor x plus 3, you put a negative 3 in the box. Then when you do the synthetic division, this is the bottom row you get. The first four numbers are coefficients of the quotient, and of course the last number is the remainder. Now, is there anybody who just needs to see one more quick synthetic division, or are we okay on synthetic division? No request for an example. That's why I typed the next several examples so we could just move through it really quickly. This function can be written as the divisor, which was x plus 3, times what would the quotient be if we were dividing an x into an 2x to the fourth? What power would we start out with in the quotient? Yeah, you subtract the exponents because you're dividing. That 2 must be the coefficient of your third degree term. So 2x cubed minus 5x squared. You could put in plus 0x, but since you're just writing your answer here, 0x is 0, you don't have to write it down. That 3 is my constant, and then the remainder is negative 9. You could either write plus negative 9 or just minus 9, and that's how you would check your answer. And we talked about that in the first two examples, how you would check your answer. You multiply your divisor by the quotient. I made that parentheses too big, but multiply by the quotient and then add your remainder. In my math lab, I think these problems, there's just a box that you type the quotient into. That would be these three terms, and a box that you type the remainder into. That would be the negative 9. All right, so example 4, we're dividing a third degree polynomial by x minus 2. That's why I have positive 2 in the box. I wasn't missing any terms in the dividend, so I did the synthetic division. I want to write this answer as the divisor, which was x minus 2, times, what's the quotient? negative 4x squared minus 6x minus 15, and then the remainder you could either write plus negative 40 or just minus 40. But make sure when you're typing your answer in My Math Lab, you do say the remainder is negative 40. Type the negative in as part of the remainder. All right. Now, remember, this is all leading up to something big, and y'all are just hanging with me for a little while. Look at the next note that I wrote for you. If you let x be 2, if, for example, I gave you this original function, f of x, and said find f of 2, what does that mean? How do you find f of 2? 2 in place of all the x's, and you just get a number for the answer. And I could absolutely do that here. I could say negative 4 times 2 cubed plus 2 times 2 squared minus 3 times 2 minus 10. I'd get a number for that. But look at this equivalent expression and see what you would get if you put a 2 into it. If these are equivalent, then I should get the same answer, but this one's much easier to evaluate. Because if I let x be 2, what is this first factor? 0, and 0 times a bunch of stuff. It doesn't matter what the bunch of stuff is. 0 times anything is just 0. And then minus 40 would give me negative 40. That's leading up to a big theorem, the remainder theorem. If a polynomial f of x is divided by x minus some constant, in this case the constant is 2. If f of x is divided by x minus a constant, the remainder is the same thing you would get if you just plug that constant into the original function. Now, I'm not giving you a harder way to do something easy. If you just gave me this function and said find f of 2, I wouldn't use synthetic division to find f of 2. I would just plug 2 into the function. But you're just supposed to be noticing something here. If you use synthetic division with 2 in the box, and then you find f of 2 using this instead of that, it always just turns out to be the remainder, because the divisor, if you let x be 2, is going to be 0. The next two examples say for the given polynomial, use the remainder theorem and synthetic division to find f of k. Well, if you gave me f of x and then said find f of 4, but you didn't say anything about synthetic division, I would just put 4 into the place of x, punch that on the calculator, get a number. However, if you tell me to use synthetic division, I'll put 4 in the box, I'll do the synthetic division, and then because of the remainder theorem, I know that f of 4 would just be what? The remainder, 127. That's what the remainder theorem is saying. And if you don't believe the remainder theorem, you put 4 into this original function and punch it on the calculator, you will get 127. So what about example 6? Find f of 2. Well, I did synthetic division with 2 in the box, and the remainder theorem tells me that f of 2 would be what? The remainder, negative 2. And again, if you wanted to double check it, punch 2 times 2 cubed minus 3 times 2 squared minus 5 times 2 plus 4. It will give you negative 2. Mr. Kevin, what's making you frown? Light bulb's just not on yet? Or so far so good? Okay, all right. It's all leading up to something big. Yes, Miss Abigail. I'm glad you asked that. I meant to say it. If I give you the divisor, g of x, then you take that opposite of the constant, and that's what goes in the box. However, if instead of the divisor, I'm giving you k is what goes in the box. If I give you a k value, that's what goes in the box. That 4 in the box actually means the divisor would be what? X minus 4. That's when I'm dividing by x minus 4 that I put a positive 4 in the box. That's what the k is. Not if it's the remainder theorem, but anytime it gives you a k value, it's giving you what goes in the box. X minus that. Yeah. All right. The factor theorem. I kind of alluded to this last Friday or Wednesday. I said if you divide a number, say 3, into some other number 12, and you get 0 for a remainder, what does that mean? A few different ways that you could say it. But what does that mean if you divide one number into another and get 0 for a remainder? It means the first number is a factor of the second. The first divides evenly into the second. You could word that either way, but that's what the factor theorem is saying. If you divide x minus k into some big polynomial f of x, and you get f of k equals 0, that means the remainder equals 0. If the remainder equals 0, then x minus k is a factor of f of x. So number 7 and 8 say use the factor theorem to determine whether the second polynomial is a factor of the first. Now, notice I wasn't given a value of k here. I'm given the divisor. I'm given x plus 1, and that's why I have a negative 1 in the box. If you ask me what is k, I would say negative 1. K is whatever's in the box. X minus negative 1 is the same as x plus 1. All right, so I've already done the synthetic division. Just answer this question for me. Is x plus 1 a factor of this trinomial? No, because why? The remainder's not 0. It didn't divide evenly. I had some left over. So you're only looking at the remainder to answer the question, is x plus 1 a factor of that? Well, not if there's a remainder other than 0. What about example 8? Is x plus 4 a factor of that big 4-term or 5-term polynomial? Yes, because why? The remainder 0. That confirms one factor or one binomial is a factor of another polynomial if you do synthetic division and get 0 remainder. And what that is all leading up to is letting us factor things that we couldn't factor before. If you just had given me this problem 10 minutes ago and said factor the function into linear factors, I would have looked at that and said, well, it has 4 terms. The only way I know how to factor something with 4 terms is by grouping. But if I group the first 2 and group the last 2 and take the GCF out of each group, I don't have the same thing left inside parentheses. Factor by grouping is not going to work on this problem. But I was given 1, 0. I was given k equals 1, and that's why I have 1 in the box. What does that mean I'm actually dividing by if I have a positive 1 in the box? X minus 1. X minus 1 is the divisor. And because I got 0 for a remainder here, I know that x minus 1 is a factor of that polynomial. What is the quotient from this bottom row of synthetic division? Exactly. 2x squared minus x minus 6. Yes, sir. It could be that you don't have a constant in the quotient. You just have 2x squared minus x. For example, you could put a plus 0 for the constant, but there would be no need to. Just like there's no need to put plus 0 for a remainder. All right, so being given one of the zeros of this function allowed me to factor this thing I couldn't factor before into a linear times a quadratic function. The directions don't say factor into linear times quadratic, though. It says factor into all linear factors. Linear means what? How do I know what a linear factor is? first degree. This is my linear factor. This is my quadratic factor. But this happens to be something I know how to factor further. This is the hard kind of trinomial. I can say 2 times 6 is 12, factors of 12 that have a difference of 1 or 3 and 4. Split that middle term and then factor by grouping. So I'm down to the point where I can finish the factoring whatever method that I would have used in chapter R. My preferred method is trial and error because I can. So I just factored that real quickly. But if you don't like trial and error and you had to go through grouping, it would have just taken you about 2 more lines. You would have ended up with the same thing. And that, by the way, is a 3. What's the most important thing you do anytime you factor? Somebody say, check your answer. Please, please, please don't miss a problem on the test because you were too lazy to say 2x times x is 2x squared, negative 4x plus 3x is negative 1x, and positive 3 times negative 2 is negative 6. If you have a sign mistake, you'll find it. Have I done what the directions said to do? Am I through with this problem? Yeah, I have 3 linear factors. I had a third degree polynomial. I was given its first 0, which allowed me to factor it into linear times quadratic, and then that quadratic would factor further using traditional methods. So I have factored something that I could not have factored before. All right, example 10, same thing. I have a third degree polynomial that I could not factor by grouping. If you gave me that in chapter R, I would have tried grouping and then I would have just said, I would have said prime. I would be wrong. It's not that it's prime, it's just that I didn't know how to factor it until today. I'm given the first 0, negative 5. If I have negative 5 in the box, what does that mean my linear factor is? You could write x minus negative 5, but minus negative is the same thing as positive. So just write x plus 5. And then what is my quadratic factor? Perfect. 6x squared minus 13x plus 2. So synthetic division has allowed me to factor this into a linear times a quadratic factor. And that quadratic factor, it might take me a minute, but I can factor it as the hard kind of trinomial. Again, by trial and error or grouping, whichever you've gotten good at. And you should have gotten good at one of them by now. Actually, I think that's going to be 6x and 1x. Yeah. There we go. That last factor is 1x minus 2 or just x minus 2. I used trial and error because I knew I could. If you had to do it by grouping, it would take you 2 more lines, but you'd end up with the same thing. And I've done exactly what the directions said to do. I have factored that into 3 linear factors. One thing that kills me on the test is when folks write an answer to this problem that makes it obvious they don't even know what factor means. If the directions say factor into linear factors, and for the answer to this problem you write down 1, negative 3/2, and 2, that's not factors. That's the zeros of the function. But factor means to factor into things that multiply back together to give you what you started with. Positive 1, negative 3/2, and positive 2 do not multiply back together to give you that original polynomial. So read the directions and make sure you know what the question's asking. If it says factor, the answer is going to look like this. If it says find the zeros, then the answers will be just numbers. 1, negative 3/2, positive 2. All right, so we're almost there. Light bulb's almost on. Example 9 and 10, I was given the first zero, and that allowed me to find the others. What if I'm not even given the first one? What if I have to find it myself? That's going to be the rational zeros theorem. But before that, the number of zeros theorem says a polynomial of degree n has at most n distinct zeros. All that means is a third degree polynomial will not have 4 solutions. A fifth degree polynomial will not have 6 solutions. It has at most as many as the degree. Now it's possible that you would have a fourth degree function that only had 2 zeros, but they would each be of multiplicity 2. That's repeated zeros. There would only be 2 x-intercepts. All right, let's figure out how to find the first zero if it's not given to me. Love the rational zeros theorem. If P over Q is a rational number written in lowest terms, and if P over Q is a zero of the polynomial f, a polynomial function with integer coefficients, then P is a factor of the constant terms and Q is a factor of the leading coefficient. Man, it's sentences like that that made me want a master's degree in math. Yeah, what the heck? If P over Q is a rational number just means fraction or can be written as a fraction, right? So if P over Q is some fraction written in lowest terms, that just means simplified as much as possible. If you give me 4/6, I'll reduce it to 2/3, and then that would be a fraction in lowest terms. If P over Q is a simplified fraction, and if it is a zero of the function, then the numerator is a factor of the constant, and the denominator is a factor of the leading coefficient. Let's see how to use that to find the zeros of a function we could not have found the zeros of before. For example, number 46, the rest of these examples you are not going to have room to write on this paper. Somebody asked me earlier, is this homework hard? You said it was going to take us a long time in class. Is it hard? It's not difficult. It's time consuming and paper consuming. Number 46. Find the real zeros of this function. Well, that would be fine if I was given the first one. I would just do synthetic division, and if you told me something was a zero, then what should I expect when I do synthetic division? The remainder should be 0, but I wasn't given the first one. I have to find it. Here's how I'm going to find it. I'm going to list the factors of the constant, and I'm not worried about the negative right now, just factors of 20, and then the factors of the leading coefficient, which in this case is 1. Let's get those factors and then figure out the rational zeros theorem. The factors of 20, I'm going to list the positive or negative, because positive 1 and negative 1 are both factors of 20. Positive 2 and negative 2 are both factors of 20. Plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Counting the positives and negatives separately, we would have 12 different factors of 20. Lucky for us, there's only there are only two factors of 1, positive and negative 1. The possible rational zeros theorem tells us my answer, my first zero, has to be a combination of these guys over these guys. Factors of the constant divided by factors of the leading coefficient. So my possible rational zeros would be each of these 12 factors divided by positive or negative 1. Dividing by 1 doesn't change anything. So if that leading coefficient is 1, my possible rational zeros are just going to be factors of the constant. We'll do an example in a minute where the leading coefficient's not 1, and you'll see that gives us a whole lot more possibilities. On a problem just like this on the test, it has an A, B, and a C part. The A part says list the possible rational zeros. That would be the answer, those 12 numbers. Now, if you had just given me this problem and said find the zeros, the universe is full of numbers that could be zeros of that function. I wouldn't know what. I mean, I would just stumble. Let's try 1. Let's try 5. Let's try negative 2. I might try numbers all day before I finally found something that made that equal to 0. There are infinitely many possibilities. But the rational zeros theorem has limited my possible solutions down from infinitely many to only 12. How can I find out which of those 12 actually is a 0 to that of that original function? Plug them in and see. Just try the 1 and see if that makes the function equal 0. If it doesn't, try the negative 1. If that doesn't, try the 2. Mr. Sullivan, the author of the text, was very kind to you. You're never going to have to try 50 different numbers to find the first 0. Let's find f of 1. If I plugged 1 into that function, I would have 1 plus 8 is 9. 9 plus 11 is 20. 20 minus 20. Wow, first thing we tried worked. I'm going to just say by substitution, we see that 1, I'm actually going to say f of 1 equals 0. So 1 is a 0 of the function. In your homework, you don't have to write that whole sentence, but you have to think that whole sentence to know what to do next. Now, before we go on, let me just say one more time, if positive 1 had not made that 0, then I would have tried negative 1. If that didn't work, then I'd try 2. If that didn't work, I'd try negative 2. But once I find the first 0, it's just like example 9 and 10. I have the first one. I can use it to find the others. I can do synthetic division with 1 in the box and the coefficients 1, 8, 11, and negative 20 out beside it. And if I'm right about 1 being a 0 of this function, what do I expect this remainder to be? 0. If it's not, either I've messed up my synthetic division or I was wrong about getting 0 when I plugged 1 into the function. Let's see. Oh, I get 0. which not only confirms what I thought, that 1 is a zero of the function, but it also allows me to factor the function, which is the B part, having the first zero allows me to factor the original function into, what's the divisor? If I have a 1 in the box, what have I actually divided by? X minus 1. And what's my quotient? Look at the bottom line of synthetic division. X squared plus 9x plus 20. But actually, the directions say factor completely, factor as far as it will factor. That will factor further. It's the easy kind of trinomial. There are factors of 20 that have a sum of 9. So that factors into x plus 4 times x plus 5. And that's the answer to the B part. Yes. And that's the C part. We're almost there. The C part will say find the real zeros. And that's what you get. Once you have the function factored, just set each factor equal to 0. What would you get for the real zeros of this function? Yeah. 1, -4, and -5 is what you would get if you set each factor equal to 0. So you're right. These problems just said find the real zeros. And in my math lab, I would have to do all this work, but all I would type in is 1, -4, -5. That requires that you know what step A and what part A and part B are without being told. On the test, I ask you for the possible rational zeros and then the factors, kind of leading you to how you find the zeros. Don't get these two answers backwards. If you tell me the factors of this function on the answer blank for factor, if you put 1, -4, -5, I'm going to say those do not multiply back together to give you a third degree polynomial. All right. Ooh, one other question. If we're talking about the graph of this function, what's synonymous with the real zeros? What are those if we go to graph this function? Those are the x-intercepts. So just like last night's homework, we have found the x-intercept. Last night it was easy because the function was given to me in factored form. Tonight, it's a little bit more time consuming, but you don't have as many problems in the homework because I know they take a while. You're still finding the x-intercepts, and then there could be a D part down there, graph the function, which we're not going to do on this problem. All right. Any questions about 46? All right. Let's do 48. Not 48, 56. The directions just say find the real zeros. If I didn't know the rational zeros theorem, I would just randomly plug in numbers and hope that someday in the not too distant future I would find something that made that 0. But the possible rational zeros theorem narrows down infinitely many possibilities to a rather small, compared to infinity, a rather small number of possibilities. I just need to list my factors of the constant, which is 2, and the factors of the leading coefficient, that's 3. The factors of 2 are just plus or minus 1 and plus or minus 2. The factors of 3 are plus or minus 1 and plus or minus 3. So my possible rational zeros are all possible combinations of these factors of 2 over these factors of 3. The easiest way for me to make sure I have them listed is put the 1 over 1 and then the 2 over 1. The 1 over 3 and then the 2 over 3. 1 over 1 is just 1. 2 over 1 is 2. 1 over 3 is 1/3 and 2 over 3 is 2/3. Although it's not fun to use, it takes up a half a page, the possible rational zeros theorem has narrowed down infinitely many possibilities to only how many possibilities? Well, 4, but then the plus or minus counted separately, 8. There are only 8 possible rational zeros. How will I find which of them actually is a zero of the function? Substitution, that's exactly the word I was trying to ESP to you. Substitution. Try the 1. If it doesn't work, try the -1. Actually, think about this for a second. If all of these coefficients are positive, is there any way I could put a positive number in place of x, add up a bunch of positives, and get 0? You can't add up a bunch of positives and get 0. So I've automatically eliminated 4 of the choices. Now I only have to try possibly 4 different things by substitution. Let's try the -1. You can punch it on your calculator. You can do it in your head, whichever one helps you get it right. If I let all these x's be -1, I would have 3 minus 4 is -1. Plus 7 is 6, minus 8 is -2, plus 2 is 0. -1 is a zero of that function. The best way to get these words in your head is to write them down. When you were 1 year old, did you know a red octagon meant stop? You didn't know that when you were 1. The word stop only became associated with a red octagon in your head after you had seen many stop signs. And mom or dad had stopped the car many times at those red octagons. Your brain has to learn to associate one thing with another thing. You need to associate getting 0 as, hey, I have found a 0 of the function. And then what do I do next? Well, I do synthetic division with -1 in the box and pray that I get what for a remainder? 0, because if I don't, I'm wrong about this. Let's see if we get a 0 remainder. I'm not missing any terms. My coefficients are 3, 4, 7, 8, and 2. I did get a 0 for a remainder. That confirms that -1 is indeed a 0 of the function, but it also allows me to factor the function. Now again, on the test, this would be an A part, and then there would be a B part, factor. If I've divided with -1 in the box, then what is one linear factor of this function? If -1 is in a box, then x plus 1 is a factor, and looking at the bottom row of synthetic division, what's another factor of this function? Yeah, make sure you realize we started out with a 4th degree function, so synthetic division's only going to get it down to 3rd degree for us. 3x cubed plus 1x squared plus 6x plus 2. But the directions say factor completely. You know what? There's a theorem that I didn't type for you that said any polynomial function, no matter how big or how ugly, can be factored at least into linear times quadratic. Every polynomial in the whole world will factor at least into linear times quadratic, maybe even all linear, but that's not guaranteed. So I know this isn't factored as completely as possible. Could I factor it using some other method that I already know, or do I need to use rational zeros theorem again? I think grouping might work on this one. If grouping works, then I don't have to use rational zeros theorem anymore, but if grouping doesn't work, that's exactly what I'll have to do. Let's see. Now we have factored this original 4th degree function. Here's the original 4th degree. We have factored it into 2 linear factors and a quadratic. Would that all multiply back together to give me a 4th degree function? Yeah, if you just add up the exponents, they would still give me 4. Will it factor any further? How about that x squared plus 2? My only guess would be x plus 1 times x plus 1, but that doesn't multiply together to give me x squared plus 2. That won't factor any further. So I have factored completely. And that's what the B part on the test asks for, factor completely. Another thing that some folks do wrong on the test frequently is leave off that first factor. They did synthetic division with -1 in the box, but forget to write down x plus 1 as a factor. If you don't have x plus 1 as a factor, does that multiply back together to give you the 4th degree polynomial you started with? No, you got to have that to be 4th degree. And then the C part says find the real zeros if I set each of those factors equal to 0, how many real zeros am I going to get? Why just 2? I have 3 factors. But that one would give me an imaginary solution. If I subtracted 2 from both sides, I'd have x squared equals -2, and then you're right, to take the square root of both sides would give me an imaginary solution. So my only real zeros are -1 and -1/3. How many x-intercepts does this graph have? Just 2, because imaginary zeros can't be x-intercepts. All right. There's one problem on the test that has the A, B, and C part that I've shown you on 46 and 56, although in my math lab with these directions, you would only write down or type in the real zeros. You don't have to type in anything before that. 64 says solve each equation in the real number system. The most common mistake on this problem on the test is leaving it blank. And I kind of see why. If you forget that the possible rational zeros theorem allows you to find the first solution and then you could find the others by synthetic division, I don't have any other way of solving that equation. But think about it. When these directions said find the real zeros, we got the real zeros by setting this equal to 0. That's exactly what this is. A polynomial set equal to 0. So I do it just like 46 and 56. List the factors of the constant, factors of the leading coefficient, and then my possible rational, instead of zeros, since this is an equation, I'm going to say possible rational solutions, but that's a technicality. Factors of none are plus or minus 1, plus or minus 3, plus or minus 9. I love it when the leading coefficient is 1. How many possible rational zeros do we have in the list? But the plus and minus counted separately would actually be 6 possible things, the 6 possible numbers I could have to substitute in to that equation to find my first rational zero. Positive or -1, positive or -3, positive or -9. How do I find out the first one of those that actually is a solution? By substitution. Try the 1. If that doesn't work, try the -1. Go on down the line as far as you have to. If you let x be +1, you would have 1 minus 2 is -1, plus 10 is 9, minus 18 is -9, plus 9 is 0. I love Mr. Sullivan. He was so kind to us. The first thing we tried actually was a solution to that equation. What does that allow us to do? Or what's next? Synthetic division with 1 in the box. That allows me to take this original equation and factor it into what linear factor? I have a positive 1 in the box. What's the linear factor? X minus 1 times what other factor? And that still equals 0. So I've factored it into a linear factor times a cubic factor. Is there any way I could try to factor that using something I knew before today, or do I need to go back and use the next number off my list? Until today, the only way I've tried to factor something with 4 terms is by grouping. I think that will factor by grouping. Without multiplying that together completely, can you just look at it and tell me whether or not it would give you a 4th degree polynomial if you were checking here? Yeah, it would give you 4th degree, so I'm fairly confident that that's right. But the directions weren't just factor, it was find the solutions. How many, and I think it said real. Yeah, how many real solutions does this equation have? Only one, and it is 1. There's no point in setting x minus 1 equals 0 or x minus 1 equals 0. That only gives you one solution. And the x squared plus 9, if you set it equal to 0 and subtracted 9 from both sides, that would give you an imaginary solution. So this equation, as big and impressive as it was, only has, I need to put the word real in there, one real solution, and it is 1. It has 2 imaginary solutions, but we don't care about those. By the way, if this problem did say graph, how many x-intercepts does this function have? 1. And if it said graph, f of x equals blah, 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 the original equation, I would say 1 is a 0 of multiplicity, what? I could write that as x minus 1 squared. So 1 is a 0 of multiplicity 2. What does that tell you the graph does at 1? It touches but does not cross. It does a U-turn. So again, all of this was leading up to being able to do what we did last night with equations that we could not have factored before. All right, I have 2 more examples, and they won't take us very long. 92. The reason that 92 won't take us very long is the fact that it's the exact same problem as 46. We've already done all the work. We just need to graph it. So look back at your number 46 and tell me, let's see, I'm going to make this like last night's homework. What is the end behavior of that function? Odd degree. Ooh, odd degree. So it's not a U shape with odd degree. It looks like XQ. It goes down on the left and up on the right, just like XQ, with no more than how many squiggles in the middle? You remember that little factoid? No more than 1 less than the degree, so no more than 2 squiggles in the middle. And then I could ask you for the y-intercept. How do we always find a y-intercept? Let x be 0. That's easy to do in this problem. You can just see if you let all the x's be 0, all that you'd have left is negative 20. So negative 20 is the y-intercept. The C part, the x-intercepts, that's what we were finding in number 46 when we found the real zeros. What did we have listed as the real zeros for number 46? Yep, that's what I have. 1, -4, and -5. So now all we have to do is put that information on a graph. And graphed my x and y intercepts. I know that the graph goes down to the left of the leftmost intercept and up to the right of the rightmost intercept. Looking back at number 46, what was the multiplicity of each of those zeros? All of them were of multiplicity 1, which tells me the graph does what at each of those x-intercept? Right. So cross at -5 without calculus. I don't know how far it goes up, but at some point it turns around and comes back down. Goes at least to -20, maybe even farther than that. Again, without calculus, I don't know. But at some point it turns and comes back up and crosses at 1. The only time-consuming part of that problem was finding the x-intercepts because the original problem wasn't given to us already factored. We had to do a little bit more work to find the x-intercepts than we did last night. All right, last one. graph f of x equals 4x to the fourth plus 15x squared minus 4. If I have to do the whole rational zeros thing in synthetic division, I'm going to have to pay attention to the fact that I'm missing my third degree term and my first degree term. But before I jump into something I know is time consuming, I refuse to call it difficult. It's not difficult, it's just time consuming. Before I go that route, I'm going to see if anything that I knew previously, quick and easy, would help me factor that and find the x-intercepts. Can you tell whether or not that would factor without having to use the rational zeros theorem? It's a trinomial. 4 times negative 4 is negative 16. Are there factors of 16 that have a difference of 15? It will factor. So don't do it the hard way without at least asking yourself, is there an easier way to do this problem? I'm going to factor this by grouping, and I'm going to write in my steps just for the folks who are still struggling a little bit with factoring by grouping. I'm going to write that middle term as negative 16x squared, doggone it. I'm going to write that middle term as negative 1x squared plus 16x squared. I just prefer to write the negative term in the first. Make sure that that adds back together to give you what you started with, and then factor by grouping. Anytime you factor, you got a whole lot riding on this problem, so check your factoring. Ooh, I see something that's wrong with my factoring. I'm glad I said check my factoring. What's wrong with it? I didn't put the squares here and here and here. So I'm very glad I checked that. Also, since that's 4x squared minus 1, it'll factor further. That's the difference of two squares. There's 4x squared, 16x squared minus 1x squared is 15x squared minus 4, and then that factored further. It would multiply back together to give me a fourth degree polynomial, so I'm pretty confident. And now it's just like last night. Once I have it factored, I look at the original function to determine its end behavior. It's fourth degree with positive coefficient. What happens on the ends? Both ends go up. It's also easiest to get the y-intercept from the original function, because the original function, I can see if I let both of those x's be 0, my y-intercept would be what? Negative 4. And the C part, since I already have it factored, I can tell you the x-intercepts are what? Just set each of these factors equal to 0. You get negative 1/2 and positive 1/2. And the x squared plus 4 would give you an imaginary solution, which can't be an x-intercept. So all that's left is putting that information on a graph. I know the graph goes up to the left of the leftmost intercept and up to the right of the rightmost intercept. What's the multiplicity of these two zeros? Look at this in factored form. What's the multiplicity of these two zeros? I don't know if you're too tired to answer or if you forgot what multiplicity means. It's the exponent of these factors, and it's 1. And the fact that the multiplicity is odd tells you the graph does what at each of those x-intercepts. Crosses, so crosses at negative 1/2, goes down at least to 4, comes back up and crosses at positive 1/2. Looks like a parabola.